Well, hey there, I'm Dr. Austin Perlmutter. I'm the host of this podcast, Get This Stuck Out, where we explore what is keeping our brains and our bodies stuck in unhealthy patterns and what we can do to help get that stuckness out and help to improve health. In this solo episode, I'm going to address a very specific topic, and that is the overlap between depression and serotonin. This is particularly in light of a paper that was recently published in Nature's Molecular Psychiatry that challenges the idea that serotonin is at the heart of depression or is driving much of depression at all. So, in this episode, I'm going to explore a bit of the background in depression, but I'm really going to dive into the relevance of serotonin, this molecule, in depression, and if it isn't so important to depression, what might be driving this instead. So I hope you enjoy this episode. Again, it is a solo episode, and we're going to be exploring serotonin and depression. So let's start with some basics on depression. What is depression? This is a term that we talk about a lot. I feel depressed. They feel depressed. But there is a difference between depression as it's described in the medical literature, as it's described in a clinical setting, and the way that we use this word in kind of our common conversation. So clinical depression, which is what research focuses on, is a condition that is defined by specific diagnostic criteria. And this is where you get a significant impairment in quality of life. And there are a number of kind of variables that clinicians look at to define and to diagnose this clinical depression, one of which relates to the duration, and many of which relate to the significance or severity of those symptoms. And that's different from the way we describe feeling depressed. A person may say, I'm depressed right now, or I have low mood. That is not the same thing, even though there may be some overlap in the symptoms and in some of the pathology. So, what is this clinical depression, or what is this major depression, as the term would be? It's actually major depression, is the way that we describe people who have clinical depression, as opposed to other ways of talking about this. And usually we're talking about unipolar depression as opposed to bipolar depression. So, as it relates to this major depression, there are somewhere between 250 and 350 million people right now on planet Earth that could meet criteria for this. And in certain places, treatments are obviously going to be more available than other places. It is notable that in countries around the world, low and middle income countries, up to 85% of depressed people are not getting adequate treatment. Generally speaking, depression tends to show up in women more than men. Women are more than twice as likely to be diagnosed with major depression than are men. And in the United States, the people who are most likely to be diagnosed with depression are people between the ages of 18 and 25. In the United States, about two-thirds of people with major depression are getting treatment for their condition. So that's where we are as far as what depression is, as far as what depression looks like in the world right now. But of course, we've been learning about this condition for a long time. It's not like modern humans are the only ones suffering from clinical depression. I guess they're the only ones who are meeting the criteria because we're applying those criteria in medical offices. But as early as ancient Babylon, which was 4,000 years ago, there's description of a state with frequent nervous breakdowns, with sleep disruptions, many of the things that we actually do see with major depression. And back then, they thought that this was being driven by basically making people's gods upset or making the gods upset. And then in ancient Greece, they described a condition called melancholia, which is very similar to what we would describe as depression now. And they thought this was due to a buildup of unhealthy bile that would come out of the spleen. So we've come a little ways as far as talking about things like serotonin as a driver of depression. But I do want to just put in this context of we've been trying to figure this out for a long time. And there's some hubris in assuming that just because it's the modern day, we have all of the answers. I think we don't have the answers to many things, even though there has been a lot of scientific breakthrough. And mood disorders, especially depression, have been one of the more challenging things to really get our hands around as it relates to what is going wrong in the brain. So, as I said, we're going to focus here more specifically on the serotonin component of depression rather than the overall picture of depression as it relates to the neuroscience. And if you're interested in some of the other pathways, you can check out my prior podcast videos and audio. But as it relates to serotonin, this is kind of an offshoot of what is called the monoamine hypothesis. And monoamines are molecules that include dopamine, norepinephrine, epinephrine, and serotonin. The idea here is that in the 20th century, researchers were able to show that drugs that influence monoamines, and these are not conventional antidepressants. This is before those were a thing. So it would be things that would influence, let's say, histamine and allergies. And actually, one of the drugs was an anti-tuberculosis medication. In essence, they found that these drugs that targeted these molecules called monoamines seemed to be associated with better mood in people who took them. So by targeting these systems, people tended to feel better. And so this was kind of the initial spot of the monoamine hypothesis. This progressed somewhere around 50 to 60 years ago to the serotonin hypothesis. And serotonin is one of the monoamines. And the reasons why serotonin kind of emerged as a potential significant player within this larger conversation of these molecules in the brain is because there was evidence that depleted serotonin or lower levels of serotonin might be linked to depression, and increasing those levels of serotonin might be linked to antidepressant effects. But really, where this came from was a lot of animal and kind of cell-based studies. And so there are a couple of human lines of evidence here. One was, and probably the biggest one was, that drugs that were supposed to increase serotonin effects, increase serotonin function in the brain, best example being selective serotonin reuptake inhibitors or SSRIs, seem to improve people's mental health. So the idea here would be if these drugs improve people's mental health and they worked by improving serotonin function, then serotonin function was probably the mechanism of depression. This was also based on the fact that when they lowered tryptophan levels, tryptophan being the precursor molecule to serotonin, in people with depression, it tended to worsen mood, or people with a predisposition to depression, it lowered mood. This is, there is some research around this. It hasn't been super consistent. It's notable, too, that when you lower tryptophan levels in healthy people, people without depression, without a family history of depression, it doesn't really seem to do all that much. So what are the issues with this, with the serotonin hypothesis, even before this recent paper came out in Nature's Molecular Psychiatry? Well, one is that these medications, these antidepressants, are thought to increase serotonin in the brain almost immediately. We're talking hours, maybe days, potentially even faster. And yet, for people to see a significant effect from antidepressants, often we're waiting for weeks, potentially even over a month to see those effects. So from a kind of biological perspective, as far as mechanism of action, there were some issues there. Another big issue with the serotonin hypothesis is that serotonin-related drugs like SSRIs, even if they did increase serotonin in the brain, they weren't working for a large proportion of people with clinical depression. So depending on the study you look at, around a third of people, or potentially more, are not really getting adequately managed with these drugs as it relates to their depressed symptoms. So again, there are some issues there. And then, as I mentioned before, when you lower healthy people's tryptophan levels, tryptophan turns into serotonin, they didn't really experience symptoms of depression. So there are a number of reasons for which serotonin as the unifying theory of depression wasn't really explaining what we were seeing, what was going on. So in the context of this, I'll just say this isn't necessarily a conversation as to whether SSRIs work. That is another conversation. There's a debate on both sides, and we can get into that in future episodes. I do think it is clear, though, that whether or not you feel like SSRIs are effective medications, they do come with a high percentage of side effects. Somewhere between 40 and 50% of people may experience things like GI effects, sexual effects, and other side effects when they take these medications. Withdrawal effects are a real thing. 50% or so of people experiencing these withdrawal effects. And the point here being that, again, if it's so selective for serotonin and so specific to what's happening in the brain, many of these side effects don't exactly make sense, even though there are serotonin receptors throughout the body, including in the GI tract. So let's now jump into this paper. This is a paper that was published on July the 20th of 2022. So depending on when you listen to this podcast, at the time I'm recording that, this is last week. The paper was called The Serotonin Theory of Depression, a Systematic Umbrella Review of the Evidence. And again, published in Nature's Molecular Psychiatry. This is basically a review of reviews. It's an umbrella review, which means they were looking at things like meta-analyses and systematic reviews. It was kind of a overall review of the reviews. And the goal of this paper was to get a sense as to the strength of the connection between serotonin issues and the diagnosis of or experience of clinical depression. So the researchers approached this subject from a range of different perspectives. They looked at everything from serotonin breakdown products in the bloodstream to looking at serotonin receptors, specifically the 1A receptor, to looking at the serotonin reuptake transporter, which is located, a little bit of trivia, on the presynaptic neuron, as well as looking at genetic differences in these transporters and how that is affected by environmental factors. So a number of different variables were considered as it related to exploring the connection between serotonin and depression. So what did they find? Well, let's start with serotonin and its breakdown products. They found no association between the breakdown products of serotonin and depression. They found no association between plasma levels of serotonin and depression. They actually, if anything, found that serotonin levels may be a bit lower in people receiving therapy for depression. How about as it relates to receptors? So again, they looked at the 1A receptor. Now that's notable because there are 14 different serotonin receptors and they have different effects. For example, psychedelics bind to and activate the 2A receptor, and certain antipsychotics may have the opposite effect on that receptor. So when we're talking about the 1A receptor, that is one that has been increasingly the kind of center point of study of SSRIs and antidepressants, but it's not the only one. In any case, they found that the serotonin 1A receptor binding was not really associated with the changes they would expect to see if it was associated with depression as far as serotonin. And then when they looked at that serotonin receptor or serotonin reuptake transporter, they found that there were not significant associations between that transporter, between genes associated with that transporter, or between gene environment associations with that transporter that would explain depression. So they kind of put all of this together in this study in their conclusion, which was there is not good evidence to support the idea that serotonin is kind of a causal or major factor in explaining depression. So really here a big conclusion from this paper, and obviously a lot of people, myself included, are thinking about this, are talking about this. So let's now move to what does this mean? To begin, I think it's important to say that a lot of people have understood that depression wasn't just about serotonin, and the idea that everyone was out there basically promoting this theory is not quite right. Many people, many researchers, many people in the lay public have been talking about depression being a multifaceted and having multi-pronged inputs that relate to the experience of depression. And this makes perfect sense. So in certain people, if they were eating a specific diet, it may be that diet is strongly correlated with their depressive output. So other people who had a traumatic event in their life may have more of a stress input on their depressive output. Depression isn't some sort of standardized thing where everyone who is experiencing depression is experiencing the same thing. And some good examples would be that certain people eat a lot more when they're clinically depressed. Other people don't eat at all. Some people sleep a lot more. Other people don't really sleep very much. Some people feel high energy. Some people feel low energy. The point being, depression isn't some specific thing that is the only result of one specific change in the brain. So with that as context, I think what this does to this study is it necessitates our reevaluation of both what might be contributing to depression and what we can do to target the things that may be involved in depression. And something that I've been talking about for many years is the idea that there are several systems in the brain that appear to be dysregulated or otherwise altered in people with depression. One of those systems, of course, is the serotonin system. But to go outside of this being just the result of serotonin levels is important. And why is that? It's because serotonin isn't the only part of the serotonin story. For example, when the tryptophan molecule is broken down in the brain, it can turn into serotonin, but it can also turn into other metabolites, some of which may be neurotoxic, some of which may be neuroprotective. So if you move just one step backwards from it's all about the serotonin levels and say, well, maybe serotonin is a part of the pathway that is involved with depression, you start to get a more comprehensive picture of how it is a piece, but not the complete picture of what's happening in the brain. One of the areas that I've spent a lot of time focusing on and that is increasingly gaining traction is the idea that depression may be related to our immune state, and specifically the immune state of our brains. So a lot of recent research has indicated that higher levels of inflammation in our bodies, in our brain, may be associated with increased risk for depression and treatment resistance in depression. And so looking at inflammatory levels of things like CRP, interleukin 6, interleukin 1 beta, tumor necrosis factor alpha, these are all molecules that are elevated in inflammation. Researchers have found that when those levels are higher, people have a higher chance of having depression. There's also some indication that the brain's immune cells, which are called microglia, may have increased activation in people with depression. Why is this important? Well, interestingly enough, certain antidepressants may in fact lower or augment our immune state, meaning lowering inflammation or augmenting our immune state. So that's really interesting. Secondly, even if you want to take serotonin out of the picture, inflammation changes the breakdown of tryptophan and may promote the buildup of these neurotoxic mediators. So it's part of that story too. What I think is so key as it relates to understanding the effect of inflammation on our brain function as it relates to depression is that we can change our inflammatory status through simple lifestyle factors: diet, sleep, exercise, even nature exposure, certainly stress and our stress management. So if inflammation may be leading certain people to develop depression, it would make sense for us to ask how we could augment specifically lower levels of chronic inflammation as a preventive and potentially a treatment strategy for depression. So beyond inflammation, what else may be responsible for depression? I have addressed this in previous interviews and in previous podcasts, but neuroplasticity or trophic factors. This is the idea that within our brains, we are sensitive to certain molecules called neurotrophins that can change the way that our brains are wired. And specifically, they can augment what is called neuroplasticity. Neuroplasticity is a fancy way of describing the fact that our brains are always rewiring themselves at any given moment, any given time. And several lines of research suggest that neuroplasticity is having issues in people with depression, that when people are depressed, there's evidence for problems with healthy neuroplasticity. A lot of this research concerns a molecule called BDNF, brain-derived neurotrophic factor, which is a protein that is involved with healthy neuroplasticity. And interestingly, people with depression have been found to have lower levels of BDNF. Also interesting, conventional antidepressants, as well as things ranging from ECT to psychedelics, may in part exert their positive effects by increasing neuroplasticity in the brains of people with depression. So that's number 2, is neuroplasticity. I think it's remarkable that we may be able to positively increase neuroplasticity by things as simple as exercise. So that's a great little bit of news for people looking at why lifestyle factors may positively influence mood. And there's actually several studies, including some recent studies, concluding that exercise may be a viable antidepressant and a depression prevention strategy. So that's number 2. And number 3 would be looking at endocrine as well as metabolic pathways that may be involved in the brain that may contribute to depression. So I'm just grouping these here because they're mostly hormonal pathways, but you've probably heard about the hypothalamic pituitary adrenal axis, or HPA axis, or stress axis. This is a series of hormones. You may be familiar with cortisol that has been found to be having changes in the context of depression. So it's notable that people with significant stress are at much higher risk of developing depression. It's also notable that one event of significant stress in a person's life increases a person's chance of developing depression after this. And some of the reasons for this may relate to this HPA axis, and high levels of chronic cortisol, which is again a stress hormone, may cause the brain to be at a higher risk of developing depression. Number of reasons why this may be the case, involving damage to or atrophy in areas of the brain like the hippocampus and the prefrontal cortex. But also notably, sustained high stress may increase inflammation. Sustained high stress may decrease neuroplasticity. So some important integrations there. And I also want to extend this endocrine metabolic conversation to other hormones, things like estrogen and insulin. So, for example, women have been found to have a higher chance of developing depression after menopause, which correlates with the timeline of when estrogen levels drop. Similarly, there's some recent data suggesting that people with high blood sugar for sustained periods of time, for example, diabetes and even prediabetes, may be at a higher risk of developing depression. And one of the reasons for this may again relate to inflammation. Higher blood sugar for long periods of time may induce higher levels of inflammation. But it's also notable that insulin and glucose are kind of essential for healthy brain function. So if there are issues with insulin and glucose signaling, as are the case in people with metabolic imbalances, which are now found to affect probably about 90% of Americans, it is notable that these may be contributing to depression. Okay, so we've covered a lot. We've talked about depression a little bit generally. We've talked about serotonin. We've talked about serotonin in depression. And we've talked about some of the reasons why serotonin may not be the best explanation for depression based on this recent study. And we've talked about maybe some better explanations for depression. But key fact here, all of these things interact. It isn't like you can pull serotonin out or inflammation out or stress out. They all interact at the level of our neurons and at the level of our psychology. So to bring this home, I think what is really important about this is this article and this conversation in general highlight the need for us to continue to explore what may be going wrong in the brains of people with depression. And beyond this, to understand, first of all, that our world, our country in the United States, we're not mentally healthy. And by the time we need to see somebody to be prescribed a drug, I do think it's similar to other conditions like heart disease, where we've lost our best chances at optimizing our preventive variables. So it's tough, I would argue, to think that our lifestyle factors are significantly augmenting our serotonin levels. One, because serotonin in the bloodstream doesn't get to the brain. Two, because tryptophan in the bloodstream has a hard time getting into the brain in higher levels unless we're supplementing, and that's not necessarily all that beneficial based on the clinical research that I've seen. So instead of focusing on purely serotonin, if we start introducing terms like inflammation and endocrine dysfunction, as well as neuroplasticity into the conversation around depression, then we get to understanding why things like diet and exercise and sleep and stress mitigation and again, nature exposure may be, first of all, associated with better mental health, but second of all, preventive and potentially therapeutic strategies for depression. So that's it for this solo episode. If you've enjoyed this content, make sure you're subscribed to the podcast. You can always find me on my website, austinperlmutter.com, and on social media. You can also find me on my newsletter that I try to send out most weeks, where I focus on various topics related to stuckness in the brain and body and strategies that we can use to get that stuckness out of ourselves. So again, thank you for listening. Thank you for watching. I'll talk to you again soon.